building a foothold for men and women who will voyage in places far away from our home planet. We are opening the gateway to space for all humankind.
The SHERES program at the MIT Space Systems Laboratory provides research scientists with a facility to advance the field of distributed satellite systems. SHERES was specifically designed to help develop algorithms relevant to guidance, navigation, and control of spacecraft.
SHERES are these mini satellites that we operate on the International Space Station, and they're really a one-of-a-kind controls testbed to test kind of high-risk space technologies in a risk-tolerant environment. Space technologies really work in space because on the ground there's a lot of variables that are really hard to quantify.
Operations aboard the ISS began in May 2006, with a total of 5 sessions completed by the end of 2006. These sessions achieved a wide range of successes, including the demonstration of both formation flight and autonomous docking algorithms. The docking algorithms were developed incrementally throughout the 5 test sessions, making heavy use of the reconfiguration and modularity features of the SHERES design. The modules were tested piecewise and assembled together to create increasingly complex docking maneuvers. The tests culminated with a successful demonstration of 2 SHERES satellites performing cooperative docking to fixed targets, demonstrating the capabilities of safe docking maneuvers and performing the first microgravity docking to a tumbling target.
Pushed recently for distributed satellite networks, sending up kind of fractionated subsystems of these satellites. So instead of sending up one big satellite, and if one thing goes wrong on the satellite, it doesn't work. If the batteries are gone, it doesn't matter how good your communication system is. If you're not getting power from your batteries, everything is lost. Whereas in kind of a fractionated architecture, you can launch up tons of smaller payloads and kind of do each task independently. If one subsystem breaks, you can kind of send up a fix just for that subsystem. And the idea behind this is sort of that they'll be kind of really close together, sort of acting as a single satellite. So one example is communication. You can do that with a lot of little satellites, kind of making up sort of whatever dish that you're trying to get for laser communications or whatever. So sort of those sort of things is definitely enabled by formation flight and other there's a lot of applications to distributed satellite networks. Getting full coverage of stars